Hi everyone, welcome to Rodha. My name is Apurv Tandon. I'm a faculty at Rodha. In today's video, we'll be discussing question on missions and allegations as well as profit loss and discount. These are few high quality questions which we have posted in our topic test on our Rodha platform. Let us have a look at these questions. Let's start with the first question on the screen. It says a milkman prepares paneer by adding lime juice to milk. When he mixes the juice of one lemon with 2 liters of milk, he obtains 400 grams of paneer. Alright. So to obtain 400 grams of paneer, I need 1 lemon and 2 liters of milk. That is the requirement to make 400 grams of paneer. And 1.5 liters of byproduct which contains 20% milk. Alright. So I'm left with a 1.5 liter of byproduct as well which has 20% milk in it. Alright. Given that the cost of milk is rupees 40 per liter. So if the cost of milk is rupees 40 per liter, so can I say for 2 liters I'll be needing how much money? I can say 40 into 2, that is rupees 80 per liter, right? 80 for 2 liters. And the cost of a dozen of lemons is rupees 24. So a dozen means 12 lemons, right? One dozen is equivalent to 12. So for 12 lemons, if I need 24. So can I say that for one lemon, I'll be needing how much rupees? I can say exactly 24 by 12, that is rupees 2. So my 400 gram of paneer can be prepared by only investing rupees 82, right? So 82 rupees are enough for making a 400 gram of paneer, right? Now, if 82 is enough for making 400 gram of paneer, right? So for 400 gram, if I need to invest rupees 82, right? So can I say that for 1000 gram, I'll be investing 82 upon 400, which is the cost for 1 gram into 1000 rupees, that is into 1000, that is for 1000 gram, right? So this is gonna give me my answer in rupees. And if you cancel two zeros, and 82 into 10 by 4 is nothing but 205. So my cost for 1000 gram of paneer is nothing but rupees 205, right? Now, so why did I convert? So that my calculation becomes easy. Per kg is always easier to calculate rather than going for a 400 gram thing, right? So this is 205 rupees per kg, right? Now, what should be the MRP so that even after offering a discount of 14.28%, he can still earn a profit of 20%. Assume the byproduct is a waste. Okay, so this is anyways a waste, right? So I don't need this part. Byproduct is a waste, right? Now he wants to offer a discount of 14.28%, right? So discount of 14.28%. Now, 14.28% in terms of fraction is 1 by 7 because he's offering a discount. So, whenever he's offering a discount, that means it's a percentage decrease, right? So, a percentage decrease means I need to subtract the numerator from the denominator to get my multiplying factor. So, my multiplying factor will be nothing but 7 minus 1 upon 7, which is equal to nothing but 6, right? And he wants to earn a profit of 20%. So, profit of 20%, right? So, profit of 20% basically means 20% is 1 by 5. Now because he wants a profit, so profit is always a percentage increase, so I'm going to add the numerator to the denominator and my multiplying factor is going to be 1 plus 5 by 5, which is going to be 6 by 5, and this was 6 by 7, right? Now understand one thing here, guys. You should understand the chain here, that is from cost price. If I want to go to mark price, okay, then I need to apply a markup. I need to apply a markup, right? And this markup is always a percentage increase, right? From mark price, if I want to go to the selling price, right? From mark price, if I want to go to the selling price, I need to apply a discount. And discount is always a percentage decrease, right? So can I say in a way this is two successive percentage change, one increase and then decrease? So if I want to go from cost price to selling price, I need to have a two successive percentage change. Now it can be increase, decrease, increase, or both decrease, anything, right? And from cost price to mark price, can I say I can directly cost price to selling price, I can directly reach using my profit or loss percentage, isn't it? So if I try to write this in one single line, so can I say I can frame a equation here, that is CP into, let's say, F1 is a multiplying factor into F2 is equal to selling price, right? And the selling price can be written as CP into F3, right? Now where F1 is my multiplying factor due to markup, right? So this entire thing becomes a mark price, right? When I apply a markup, then this entire thing becomes a mark price, right? Then F2 is my multiplying factor due to discount, and F3 will be my multiplying factor due to the profit or loss percentage, right? Now, remember here one thing, that is because F1 is my multiplying factor due to markup, right? And markup is always a percentage increase. So in the multiplying factor of F1, the value of F1, your numerator should always be greater than the denominator, right? Because it's a percentage increase, like you see here. Markup we haven't calculated here, right? But because it's a percentage increase, so your numerator will always be greater than the denominator, whereas your discount is always a percentage decrease. So in this multiplying factor, your numerator will always be less than the denominator. For example, we have calculated the discount of 14.28%. So here if you see, it is 6 by 7. So here the numerator is 6 and the denominator is 7, so it is always going to be less, right? And F3 can be a multiplying factor due to profit or loss percentage. So if it's a profit, then numerator is greater than denominator. If it's a loss, then your numerator is less than the denominator, because loss is always percentage decrease and profit is always percentage increase, right? And like you see here, this is 6 by 5, which is profit, so numerator is greater than the denominator, isn't it? Now, if I see here, I have the value of F1, not the value of F1, I have the value of F2, which is my discount percentage, right? And I have the value of my F3, which is my profit percentage. So can I say my CP is 205? So let us substitute it here. So 205 into F1 is something that I need to find, into F2 is nothing but 6 by 7, is equal to CP, that is 205, because it is SP, right? And SP is what? CP into F3, right? So CP is 205 into F3 is 6 by 5, right? So on solving this, 205 and 205 is cancelled, 6 and 6 is cancelled. So the value of F1 is, I can say, 7 by 5, and because the value of F1 is 7 by 5, so that is my multiplying factor for the markup. And the question is asking me what should be the mark price, right? So if my cost price is 205, right, so my mark price should be nothing but 205, and on that I apply a markup of 7 by 5. So this value will come out to be nothing but, I can say, 287. So that is my required answer, isn't it? So I hope you guys could follow this fund of the successive percentage change here, which is an application of percentage in profit, loss and discount. So the required answer is definitely 287. All right, let us move ahead to the next question now. It says, in a kitchen experiment, two blends of sweet sip syrup milk are prepared. Okay, one blend has 40% sweet sip syrup while the other has 90%. Okay, so there's one blend which has 40% sweet sip syrup and the other one has 90%. So let's say blend 2, right? Now, these blends are then mixed together in a certain proportion to create a solution containing 60% sweet sip syrup. Okay, so the average here is 60%, right? So those of you who are not able to figure out why am I writing it like this, let us understand a bit over here, right? So we know that weighted average, that is C average, is given by C1W1 plus C2W2 upon W1 plus W2, right? So if I rearrange this equation, right, if I multiply, so I say I'll get CaW1 plus CaW2 is equal to C1W1 plus C2W2, right? And if I bring the W1 terms together on the left hand side, I'll get Ca minus C1 into W1 is equal to, I can say, C2 minus Ca into W2. So I have put the W1 terms together and the W2 were two terms together, right? So from here, if I try to find the ratio of W1 by W2, right? So W1 by W2 from here comes out to be nothing but C2 minus Ca, which is my C average, right? Weighted average upon Ca minus C1. And the diagrammatic representation of this itself is called as your nothing but alligation rule, right? So if I represent this in a diagrammatic manner, that is, I put C1 on one side, C2 on other side, and C average in middle. So I can say one of the values is Ca minus C1 and the other value is C2 minus C, right? So this is my ratio of the two weights, that is W1 upon W2, so the quantity. So applying the same rule here, why? Because we have one blend as 40%, one blend as 90%, and there's another blend which is 60%, which is a mixture of these two, right? So this is the average, isn't it? So if this is the average, if I apply alligation rule here, 60 minus 40 is 20, and 90 minus 60 is, I can say, 30. So the ratio of mixture of 1 to 2 is going to be nothing but 3 is to 2, right? Now let's see it further. Following this, 5 liters of water is added to the resultant solution to achieve a mixture containing 50% sweet syrup. All right. Following this, okay, so the resultant is how much? I can say my resultant solution is a 60% sweet syrup, right? In this, I'm adding water 5 liters, okay? So in water, now there's another one that I'm gonna do here. So there's another time I'll have to apply allegation rule because that is what the question demands me to do, right? So what I'm going to do here is I have 60% on one side, okay, and on other side I have 5 liters of water. So can I say in 5 liters of water the sweet syrup is nothing but 0%? There's no sweet sip in water, right? So this is 5 liter in quantity, right? So this is the weight basically, the weight that we find, no ratio. This is the weight here, okay, and the resultant gives me a 50% sweet syrup. So resultant is 50%. So 60 minus 50 is 10, and 50 minus 0 is 50. So can I say the ratios of nothing but 5 is to 1? And we know that this 1 corresponds to 5 liter because it was given that 5 liter of water has been added. So if 1 corresponds to 5 liters, so can I say 5 should correspond to 25 liters? Isn't it? Because the multiplying factor is 5 here. So this should also be multiplied by 5. Now, 25 liters basically the 60% solution, isn't it? So this 60% solution was 25 liter. So if I divide this 25 liter in the ratio 3 to 2, so can I say this part will be nothing but 3 by sum of the ratio, that is 5 into 25, which is gonna give me 15, and then this remaining will be 25 minus 15, that is 10. So when I was mixing for the first time, so 40% sweet syrup quantity used was nothing but 15 liters, and this used was nothing but 10 liters, right? Now, what is the question asking me? The question is asking me how much of the 40% sweet syrup blend was used in this entire process. So if you see here, only 15%, 15 liters has been used in the entire process. So my required answer should be nothing but 15 liters. All right, let us move ahead to the last question now here on your screen. It says Rajiv bought 50 liters of milk at a price of rupees 60 per liter. All right, he sold n liters at a profit of n% and rest milk at a profit of 100 minus n%. This n% should be outside the bracket here. So this is 100 minus n%. Okay, so ignore this. What is the minimum profit that he could have earned? All right, so he has bought 50 liters at a rate of 60. Okay, now profit from n liters, profit from n liters that he's selling is gonna be, I can say, first the total cost price, that is 16 to n, and on that I'm earning a profit of n%, right? So n by 100, that is my profit on n liters, right? Similarly, profit on remaining 50 minus n liters will be nothing but, I can say, the total cost price, that is 60 into 50 minus n, right, into 100 minus n%. So 100 minus n upon 100. So that is my profit from here. And my minimum profit will be nothing but sum of these two, right? But can I say my profit only depends upon this n here, right? All the terms which have n, because this 60 and 100, they have nothing to do with the profit, right? So what I can do here is I can, get rid of this also. So this will be 3 by 5, and this should also be nothing but 3 by 5, right? So my minimum profit can be obtained only by solving the remaining thing, that is n into n, which is n square, plus 50 minus n into 100 minus n, right? If I can find the minimum value of this, then I can find the minimum value of my total profit, right? Because then I just have to multiply by 3 by 5, because 3 by 5 is going to come out common in both of them, right? So let us try to find this. So this is basically a quadratic equation. Let us expand this. So what will I get? I get n square plus 5000 minus 50n minus 100n and minus n square. Sorry, plus n square. So I'll get nothing but 2n square. I can say minus 150n and plus 5000, right? So because here the coefficient of n square is 2, so let us make it 1. So I can say this equation can be written as 2 into n square minus 75n and plus 2500. Now, if I want the minimum value of this expression, right, the minimum value of n, so basically I want to find the minimum of this quadratic, right, the minimum value of this quadratic equation, isn't it? So what I can do here is, to get the minimum value of n, there are a couple of methods of solving a quadratic's minimum value, right? So let us discuss one by one all the methods here, all right? So method one is using graph, right? Using the graph. So I can say for a quadratic ax square plus bx plus c, the graph of this quadratic is a parabola which is open upwards if your leading coefficient is positive. That is, the value of a is greater than 0, where the coordinate of this point of minima is nothing but minus b by 2a comma minus d by 4a, right? So basically this is the x coordinate and this is the y coordinate, right? So even if you get the value of this x coordinate minus b by 2, and if you substitute it in this equation, you get its minimum value, right? So both the ways are there, so whatever you want to, prefer to, right? And basically here I don't want to find the minimum value of the quadratic, I just want to find the value of n at which this quadratic will be minimum, right? So that if I get the value of n, I can substitute it in this particular equation and this here and add them to get my minimum profit, isn't it? So I just need the value of n here. So basically I need this x coordinate here, right? So here the equation is, I can say n square, then I have, sorry, my bad, n square minus 75n plus 2500. So n square minus 75n plus 2500. Now if you compare it with ax square plus bx plus c, then I can say the value of b is nothing but minus 75, right? And the value of a is nothing but, I can say, 1. So the minimum value of n, the value of n at which this quadratic will be minimum is, I can say, minus b, that is minus of minus 75 upon 2a, which is 2 into 1. So this value comes out to be nothing but 37.5. So if I substitute the value of n as 37.5, I'll get my minimum profit. And what is my minimum profit? If I go back, I can say it is nothing but n square 3 by 5 into n square plus 3 by 5 into 50 minus n into 100 minus n. So I can say my minimum profit is 3 by 5 is common. I can say n square plus 50 minus n into 100 minus n. So if you substitute the value of n as 37.5 in this equation, you'll get nothing but your required minimum profit, which will come out to be nothing but, I can say, 3 by 5 into 37.5 whole square plus 50 minus 37.5. So 50 minus 37.5 is, I can say, 12.5, right? And 100 minus 37.5 is nothing but, I can say, 62.5, right? So these are my given values. So on solving this, you'll get the minimum profit, which comes out to be nothing but 1312.5, right? Now, there are a couple of other ways to get the same value of n, right? So one of the method is the graph method that we have already discussed right now, right? Let us move ahead to the second method, which is my using differentiation, right? So method 2 is using differentiation. Now, those who are aware of differentiation can easily do it with the help of differentiation, right? It's a pretty easy way to do it as well. And people who are not aware of differentiation can stick to the method one that I've just told in the previous slide, right? So we have the equation as n square minus 75n plus 2500, right? So let me differentiate it with respect to n. So if I differentiate it with respect to n here, so I can say n square differentiation is nothing but 2n, right? We know the formula, that is d by dx of x to the power n is always given by nx to the power n minus 1, right? So this is going to be 2n minus 75, and differentiation is going to be 75, right? So 2n minus 75, and differentiation of a constant value is nothing but 0. So the differentiation is coming out to be nothing but d by dn is coming out to be nothing but 2n minus 75. And if you want the minimum value, then you put d by dn as 0. Whenever we want to find the minimum value, with the help of the differentiation, we equate it to 0. So from here, if I'm equating this to 0, then the value of n will come out to be nothing but 75 by 2, which is 37.5, right? And again, you can substitute the same value in the given profit equation, which is here on the previous side, where I have done the calculation part, this one, right? This we did. So same thing, you can substitute here and you'll get the same result, that is 1312.5, right? Another way to, get this minimum value of n from a quadratic is by making it a perfect square, right? So by making it a perfect square. So how do we make a perfect square? Let's understand that. Okay. So for making it a perfect square, this equation here, right? we have n square minus 75n plus 2500. Okay. So for making a perfect square, we add and subtract the square of half of the coefficient of n, right? So half of the coefficient of n is nothing but 37.5. So I can say I can also split it. Either you add and subtract the coefficient of the half of the coefficient of n square, right? So basically half of 75 is 37.5. You add a perfect square of 37.5 and you subtract as well. Or what you can do is n square, you can write it like this as well. N square into minus 2 into 37.5 into n, right? So if I compare it with a square minus 2ab, right? So there's a b here, so b corresponds to n, so there's a n square here, right? Let's say a corresponds to n. Okay, so if a corresponds to n, there's a square here term, right? If b corresponds to 37.5, then there should be a b square. So I can say I need a plus 37.5 square, which is nothing but 1406.25, right? So from 2500, if I pulled out 1406.25, then I can say the remaining will be nothing but 2500 minus 1406.25, which is nothing but 1093.75. You would have got a similar result if you would have added the half of the coefficient of n square and subtracted it as well. Why? Because 37.5 half square would have been this much, right? So you have added this and you subtract this also. So if you subtract this, this is going to give you the same result here, right? So it doesn't make a difference whether you convert it into a perfect square by pulling out a number from here, right? Or you add and subtract 1406 2.5. Ultimately, you're going to end up with this equation itself, right? So I can say this is going to give me nothing but, I can say n minus 37.5 whole square plus 1093.75, right? Now, if you want this entire expression to be minimum, right? So when will this entire expression be minimum? When this perfect square is 0. And when will the perfect square be 0? When the value of n is nothing but, I can say, 37.5. So whether you use the graph or you use differentiation or you use perfect square method, in each of the three cases, I'm getting the value of n as 37.5 here. And whenever I substitute this value of n as 37.5 in this my equation of minimum profit, I'm always gonna get my answer as, I can say, 1312.5. So the minimum profit that Rajiv could have made is nothing but 1312.5. So that is my required answer. All right. Thank you, everyone. We guys will meet in the next video. Thank you, everyone. We'll meet in the next video soon. Thank you, everyone.